Welcome back. In the last session, we have talked about what a variable is, the characteristics we measure. But note that not all variables are created equal. The type of variable you have determines the type of analysis you can do, the graph you can make, and the story you can tell. Today, we are diving into the two main forms of variables, qualitative and quantitative. Understanding this difference is like learning the difference between words and numbers. It changes everything. Let's begin. We have two types of variables in statistics, qualitative and quantitative. One limitation of statistics, as you know, is that it primarily deals with numerical data. Therefore, for a variable to be analyzed statistically, it must be either be quantitatively, which is already numerical, or qualitatively, but capable of being transformed into numbers through coding. Two forms of variables, qualitative, quantitative. What does it mean, qualitative variable? Qualitative variable is nothing but non-numeric, whose value not expressed by numbers. These are labels or categories. They answer questions like what kind, what type, which group. With these variables, you cannot do mathematical operations meaningfully, right? Examples are all around us. For example, sex or gender, male or female, right? Your favorite color. It could be red, white, yellow, blue, or something else related. Gender is nothing but either male or female. These possible values are not numbers by nature, but words. This makes these variables as qualitative or categorical variables. When we proceed to quantitative variable, these are nothing but numerical and can be obtained by measurement, right? Variables that can be expressed numerically by nature are nothing but quantitative variables. These quantitative variables answer questions like how many or how much. As they are numerical, we can measure and perform calculations on them meaningfully, like finding arithmetic mean, calculating correlations between variables, or performing other advanced statistical calculations. Further, quantitative variables can also be divided into two, discrete and continuous. Discrete quantitative variables are nothing but separate, distinct numbers expressed using whole numbers, right? For example, number of children in your family, number of calls received by an operator, number of accidents, number of beds in a hospital, number of patients. These all are examples of discrete quantitative variables. With this type of quantitative variables, we cannot say have a child or 1.3 accidents. Rather, no child, one child, two children, three children, right? This can only be described by whole numbers. So these variables are all about counting, right? Whereas continuous variable can take on any value within a range. These are all about measuring. For example, temperature, weight, height, area. These all are continuous variables. Here 175.5 has a meaning. 17.5.0 has a meaning, right? So before getting into difficult analysis stages in statistics, we need to identify the properties of these two variables. Let us see this example of variables from agriculture. These on the top are variables such as seed type, number of plots, farm size, fertilizer. These are variables. So what we need with these variables is nothing but to classify whether each of these variables are qualitative, quantitative, discrete, continuous, and the appropriate questioning type. The fourth one, to identify the possible values or the possible response of each variables. For example, seed type is a variable where it is qualitative variable type, and the questioning type is what kind, what type, which group, is right? The possible values or the possible responses for such variable is nothing but improved, local, right? In this context, seed type can be improved or local. These are the possible responses. It depends on the specific research type. When we process number of plots, this is another possible variable. As the name indicates, this one is quantitative, but it is discrete type. As the questioning type for such variables is how many. It is not what kind, it is not how much, but appropriate questioning will be for those discrete quantitative variables, how many. For example, how many children do you have? How many students are there in your class? How many calls you have received today, right? This is a possible questioning. For example, a farmer may have 1 plot, 2 plot, or 3 plot, 4 plot, or 0 plot, right? For a farmer having nothing, 0 plot. For the third variable, which is farm size, this farm size indicates the area of the farm that the farmer can own. This farm size is quantitative variable type, in particular continuous. So the appropriate questioning for such variable is how much area, how much weight. So the response could be, the possible response could be 1.5 hectare square, 2.25 hectare square, and much more. For the fourth variable, fertilizer, amount of fertilizer, is similarly quantitative continuous type. In the questioning, relevance is how much. So the response could be 100.5 kilogram, 150.75 kilogram, right? Distinguishing variables in such a way that is important for smooth analysis and presentation, even interpretation stages. Well, the next important section is why variable types matter in statistics. Understanding variable types shape how we analyze data, how we present findings, how we interpret and communicate insights. For example, for those qualitative variables, what the appropriate analysis method will be computing of frequencies, right? Counting the possible occurrence of events or of categories or the possible values of the variable under investigation, right? Or we compute proportion. The appropriate presentation table for qualitative variable are nothing but such as bar chart, pie chart, frequency table. While the interpretation style with such variables is nothing but, right, identifying category dominance, right? For example, most of the students in my class are female, right? Majority of the farmers use it improved seeds. This is nothing but we are interpreting the proportions here computed under the analysis method. Similarly, with quantitative discrete variables, we can compute count, proportion, incidence, similar to that of qualitative variables, right, as analysis method. The appropriate presentation table for such variables are nothing but bar chart, frequency table, and even pie chart if the possible values of the variable is small in number. With this, we can narrate with the total occurrences, event frequency. This is nothing but we interpret related to this analysis results, right? How many incidents are occurred with one possible value of the variable. With the continuous, the appropriate analysis methods are nothing but mean, median, range, correlation. These are appropriate. But we cannot calculate mean for qualitative variable. We cannot find range for qualitative variable. But computing these measures of central tendency and correlation figures are for quantitative continuous variables. Presentation table, histogram, ogive, box plot are appropriate for those variables which are quantitative, continuous in particular. When we interpret these findings, we connect with trends, right? Increasing, decreasing trends, variation, to what extent those values are scattered around their measures of central tendency, distribution shape, quartets, skewness can be interpreted regarding this histogram presentation tool, even with these findings, right? So from this we can understand that the type of the variable determines the analysis method, presentation tool, even the interpretation style.